Hi YouTube, and welcome back to another video. In the last video, we talked about layouts. We talked about how you can manipulate the items within a layout, what it means, and when you would use them. And a layout kind of groups things together, in my opinion. And you can do the offset and cardinal directions, and you can do fancy stuff like attach this node or this object to the main object, and as you rotate the main object, all your other objects are going to be manipulated and changed based on that, using things like bottom left or right or top left or any of these ones that you see on the screen. You have the Flexbox configuration, and Flexbox is how do you arrange your items on the screen. And there's different configuration properties that we have available to us. We can also group our things in a different way and then manipulate our items based on the group. And if we look at the example that we have here, you have our group. Our group is right here, so this node is a group. And we can set the opacity without affecting anything else on the screen. And we do that with layouts. Now, in today's video, we're going to talk about signals. So signals represent a value that may change over time. They can be used to define dependencies between the state of an animation. This way, when a value changes, all the other values that depend on it will get automatically updated. And you've seen signals before. When we went over to the positioning example, if I hit view source code, right here we have create signal on scale. And I mentioned that we wouldn't, or that I was going to go over create signal at the end of that video when I talked about positioning. Unfortunately, I did not. I'm sorry. And we saw that we used scale here, which was coming from up here for create signal. And now we'll actually talk about signals in this video. So signals for primitive types are created by using create signal, where the first argument specifies their initial value. So in our example, our initial value was 1. Additionally, each complex type has a static create signal method that can be used to create a signal for said type. So we have vector2 create signal, and so on and so forth. Properties of every node are also represented by signals. So we can have a circle equals a new circle. This is JSX. We could also just put new circle if you just want to use regular JavaScript. And signal can equal circle.fill. And then we have, once created, a signal can be invoked to perform one of 3 possibilities. You can retrieve a value, update a value, and create a tween for a value. And if we haven't really talked about tweens yet, I will. Tweens will actually be in a few videos from now, but it essentially allows you to manipulate things, including time. So everything that we've done so far is a tween. I'll get to that in a later video. But this right here is a tween. So in our past examples, like in this one, for example, all of these functions are really using signals behind the scene. It's the glue that keeps everything working. Okay. So instead of the actual value, the signal can be provided with a function that computes the value dynamically. Consider the following example. So radius, so you have a signal with a default value of 1, or the initial value of 1, sorry. You set that to be the radius. Your area, you create another signal, and that initial value is the area, what looks like of a circle. So for that, we have our area, which we set here. And then we have the radius. We set the radius equal to 2. Every time you call area, you're really calling this function. That function runs when you call area. And so it's like area is a shortcut for calling this function. And we take the new value of radius, and instead of being 3.14159, we have an area of 12.5663. So here's another explanation according to the official documentation. So the area, every time this runs, area recalculated. So if we run this, the area is recalculated because we haven't calculated it before. Then we print area again. Nothing has changed. For performance reasons, you would not want to just call the function every single time. You'd create a signal so that only upon updating one of the components the signal requires do you actually recalculate it. Aside from that, it is just cached. So then we're changing the radius, which is one of the values inside of here. Area is recalculated. We change the radius again. Because we haven't called area, we're not recalculating the area. Only when we call the function again do we recalculate it. So signals are only calculated when their value is requested. The first area recalculated message is logged to the console only after area is called. And like I mentioned, there's also caching. Once the signal is calculated, its value is saved and then returned during a subsequent call to area. This is why nothing is logged to the console during the second call. It is only after we change the radius that it gets recalculated. And this is perfect for calculating computationally heavy operations. In fact, Motion Canvas uses signals internally to cache things such as matrices and all the other things. So signals are extremely important for how Motion Canvas works. Dependency tracking. The area signal keeps track of other signals it depends on. When we change the radius signal up here, the area signal is notified about that, but it doesn't get recalculated immediately. Laziness is still at play. We can modify the radius, however, many times we want, but the area will be recalculated only once its value is requested, again by calling area. Default values. So signals keep track of the initial value specified during creation. At any time, we can reset a signal to its initial value by passing the default signal. So right now, signal, which could be rectangle, it could be area, it could be whatever, is set to 3. Signal, we change it to 2. This is a setter. This is a getter. It's now at 2 because we're recalculating things. We want to change the value back to the default. So default must be a function or a special string within the create signal function that we're calling. And it sets it back to the initial one. We can also use default symbol for tweening. And we'll get to tweening in a future video. Resetting to the default value is expressively useful with node properties. In the example below, we set the line height of the text to 150%. This will override the default value, and which would simply inherit from its parent. If we want to reset the line height back to the default inherit value, we can do so with the default keyword. So in this example, we have a reference of text. we set the reference right here so that this reference is now a reference to this item. And then we take our text, which is right here, set the line height, which is right here, and we set it back to our default value, which is whatever the parent value is. A complicated example. So if we run this, we can see things are growing and shrinking. Many things are related upon each other. So if I open up the source code, I copy it, and like always, I'll paste it in here. I'll run this, and actually I'm going to do some cleanup from our last videos. There we go. Oh, and this is too big. Let's zoom to fit. And we can see we have area automatically recalculating and radius automatically calculating. We're getting more into advanced things. And let's do our experimentation as we always do. Figure out what is going on. So we get rid of the yields. And we can see that we have a radius. Our radius is 3. R is 3. That checks out. Our area is right here. Our area currently is 28.27. Our scale is 100. And our text style is this. We have our circle. And we set the width to be radius, which is up here, which is 3, times our scale, which is 100, times 2. And then our height of our circle. Then we have our line, which is start arrow, end arrow. We have dashes. And then we have points. So start with 0, 0, which is right there. And it goes to radius times scale. So half the circle, because this is the diameter. And we have our dashed lines. And end offset, line width, stroke. And then we have our text. So our text is r radius dot to fixed. So this says just have 2 decimal points of the radius. X of the text, we want it to scale to the same size of the radius. And we want to include the text style. And then same thing for here. We want to just paste what the radius is. And so if we bring these both back, wait for is just a pause. So we change the radius from 4 to 3. So the radius, go right here, is 3. So in 2 seconds, we want to change it to from 3 to 4. So if I run this, so we can see it's now 4. And in 2 seconds, we now change it over. And then after we change it to 4, we want to change it back to 3 in another 2 seconds. So it bounces between our initial value of 3 and 4. We could just put default right here and it would still work. So actually, let's put that there. What is this? Is it clear but never used? Okay, well, let's use it. And we can see it is running. And why is this? Has no exported member. Well, let's look into that. We have, it's part of core. My bad. That's better. No more errors. And as we can see, it's still using, still working, because we're using the default value of 3. So let's look at the complex example. So this is what we talked about. With this setup, all we need to do is to animate the radius signal, and the rest of the scenes will adjust accordingly because we're using these arrow functions, all based on the radius and area is based on the radius. And everything will automatically adjust accordingly, as we see here. Pretty cool. Well, if you like this video, please hit the like, subscribe, and I will see you in the next one. In the next video, we'll be going over effects. Until then, I will see you later. Have a great day.